Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode servers. Head to linode.com/changelog.
This episode is sponsored by our friends at Rollbar. How important is it for you to catch errors before your users do? What if you could resolve those errors in minutes and then deploy with confidence? That's exactly what Rollbar enables for software teams. One of the most frustrating things we all deal with is errors. Most teams either A, rely on their users to report errors, or B, use log files and lists of errors to debug problems. That's such a waste of time. Instantly know what's broken and why with Rollbar. Reduce time wasted debugging and automatically capture errors alongside rich diagnostic data to help you defeat impactful errors. You can integrate Rollbar into your existing workflow. It integrates with your source code repository and deployment system to give you deep insights into exactly what changes caused each error. Give Rollbar a try today at no cost to you. No credit card is required. Our listeners get access to the Bootstrap plan with 100,000 events for free for 90 days. To get started, head to rollbar.com/changelog.
Welcome to JS Party, a weekly celebration of JavaScript and the web. Tune in live on Thursdays at 1 p.m. US Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. Follow us on Twitter. We're at JSPartyFM. And now on to the show.
Hello there, and welcome to another episode of JS Party, where every week we are throwing a party about JavaScript and the web. I'm your MC for this show, K-Ball, and I am super pumped about today's episode because we're not just talking JavaScript, we're actually jumping over and talking about WebAssembly. And we have a special guest joining us today, Jay Phelps. Hi, Jay.
Hey, dude, that song, like now I know why it's called JS Party. I wanted to dance.
I dance every time. If you could see me, I'm here rocking out in front of my microphone. Awesome. Thanks for joining us. Also on the line, we have Suz Hinton. Hi, Suz.
Hey, it's good to be back. Thanks for having me. I'm really excited about this topic today as well.
Yeah, I think it'll be good. So we have a lot of interesting topics to discuss related to WebAssembly, but I think there's a key thing we have to figure out first, which is how do we pronounce the abbreviation? Is it WASM or is it WASM?
So that's a great question. I think it's more of a regional thing because I say WASM, but a majority of the people in the community group and in the working group call it WASM. Yeah, I honestly, I have no idea. I don't think there's a correct pronunciation. I think it's just regional. And then also, like, for me personally, WASM just feels weird to say. Like, WASM.
I mean, Jared argues that it should be WASM because then it rhymes with awesome. And so we can have our title for today. Yeah, exactly. WASM is awesome.
Exactly. But at the same time, WASM, you can be like, WASM! you know, like the Bud Light commercials.
Well, and one of our panelists, Chris Hiller, who's not on today, he wrote a poem for WebAssembly. He said, Instructions by Christopher Hiller. WASM. Hasm.
You award-winning rhymes. Yes,
we do. I didn't prepare a rap for you, Jay, but we like to goof off a little bit. So let's actually step back, since this is typically a conversation about JavaScript, and not all of our audience maybe knows that much about WebAssembly. You're one of our experts. Jay, do you want to kind of give an overview of what it is and what it enables?
Sure. Yeah, it's like the phrase that they like to use is that it's an efficient low-level bytecode for the web. But we kind of have to distill that down and talk a little bit more about what that means. Like in the efficiency side of things, it kind of means efficient in almost every single way, not just efficient as in like performant while the application is actually running, which it is. But it's also efficient in trying to be efficient in the actual size of the files, and also efficient in sending those files over the internet and then getting them compiled to the person's native machine code. So in the last couple of years, there's been a lot of discussion about the parse times of things like JavaScript, right? So like you may have worked really hard to get your bundle size down to 500 meg or less or more or whatever. And now you're looking at the performance flame graphs and seeing that, it takes a long time, especially on these mobile devices, to actually even parse and compile the JavaScript. And with WebAssembly, the goal is to do something totally different, to do what's called streaming compilation. And that means that while the browser is downloading those bytes from the internet, it can actually compile it right then and there. It parses and compiles the WebAssembly bytecode while it's being downloaded. It doesn't have to wait for the file to complete. And that's huge because in this is a fairly new feature added to WebAssembly in some browsers like particularly Firefox and Chrome. But in those instances, for example, Firefox is able to download and compile the WebAssembly, Firefox is able to compile the WebAssembly faster than it actually is downloaded over the internet on average. There's certain cases where like your internet's super fast and your computer's super slow, where that's not going to be true. But particularly on things like mobile devices, that can be huge because now the compilation, that parsing and compile step that runs in your browser is no longer the bottleneck. It's back to being the internet.
There's two things in there I think that would be worth breaking down. So one was sort of compilation as you go, which in JavaScript you kind of need to have global visibility before you can truly compile it. Is that not true for WebAssembly?
It's somewhat true for WebAssembly. It can compile it because of the way the things are broken up into sections. It's going to depend on the actual virtual machine implementation about whether it's able to compile in between different segments. Like I don't want to get too low level, but the files themselves are broken up into these segments, and the different things are organized inside the files in a way that you might not normally, like if you don't know anything about binaries and like native compiled code, it might be weird to actually distill down what the files contain because they split things. Like the code bodies of all the functions are put in different sections than like the names for the functions and for imports and for different, like all your strings and all the data segment, things like that are going to be in totally different sections. And so depending on the actual virtual machine, it may be able to compile just this individual sections separately. Like it may have to wait for that section to finish downloading before it can compile it. But I don't want to speak for them, but my understanding of the Mozilla's virtual machine implementation is that it is able to compile them as they're coming in, even within the same segments, the same sections. And that's
really cool.
Yeah, it is very cool. And so it has to, with JavaScript, there's just a lot, like JavaScript was not designed as a compilation target. It was designed as a programming language. So all these type of tricks that they can do to make things super easy to parse, super easy to compile, those are things that weren't thought of when JavaScript was being made, right? Not at all. Like it wasn't even a fleeting thought. And so that's why WebAssembly is such a great compilation target. And that's what it's intended as. It's not intended for you to write it by hand, although you certainly can, just like you can write native machine code by hand by using an assembly language, like a textual representation of the machine code. You can do the exact same thing with WebAssembly. There's a textual representation of the bytecode. And that's why that's actually one thing I wanted to talk about, which is that the name WebAssembly is actually a misnomer because WebAssembly itself is neither for the web or neither specifically for the web, nor is it actually an assembly language. It's a bytecode, not an assembly language. And so while it sounds super cool and buzzworthy, it's actually not a WebAssembly. And the reason why I'm saying it's not for the web is the specification actually is completely agnostic of a browser or JavaScript or anything like that. And that's done intentional because designing these type of this low-level bytecode, this is pretty unprecedented, in fact, where you have all these major companies coming together and deciding on an instruction set. This has never been done. Like literally, I'm not kidding, it's never been done, where all these major companies come together and create an instruction set. And so they knew that this was unprecedented, knew that this is going to be useful work outside of just the browser. And that's why they been careful to not make it specific to the web per se. Now they keep the web in mind, and certainly some trade-offs. What's that?
Oh, so something you said there got me thinking. So essentially, this is like redesigning Java bytecode or something. So you could have a global virtual machine, but instead of it being owned by a single company that someone like Oracle could acquire and do nasty things to, it's developed in the open.
Yeah, exactly. I mean, there's certainly some things that are analogous to the JVM and the JVM bytecode, and there's been a couple attempts at doing similar things to this, like creating a generic bytecode that's super low level. Like the JVM is kind of a bad example simply because it is very, like if you actually look at the JVM bytecodes, they're very specific to Java. It's very clear they had Java in mind when they were very Java in mind when they were designing the bytecodes. Whereas with WebAssembly, it's pretty generic. It's pretty low level. It's about as low level as you can get while still abstracting the underlying machine. But so I think that's important. Like it's very, very, very low level. It's not something you typically will write by hand unless you're looking for ultra performance or you're working on tooling.
Interesting. So if we kind of explore that direction, then so it sounds like what you're saying is we're calling it WebAssembly, but really the web is like the web is Basecamp, right? Everest is someplace that is essentially a universal virtual machine.
Yep. That's exactly right. And I think that's one of the most exciting things about WebAssembly to me is that it's not tied to the future of browsers and all that stuff per se. Like there already are places and people who are using WebAssembly in completely unrelated web cases. So like the Ethereum virtual machine, for example, is being rewritten to use WebAssembly as their ISA and their instruction set, excuse me. And there's other use cases as well. There's even a person who's on the community group who is trying to create an actual microkernel, like the core functionality of an operating system that runs WebAssembly natively, and like without needing to use system calls for, like if you know a lot about OS stuff, they have different like rings to the security privileges of an operating system. And with WebAssembly, the way it's sandboxed, you actually don't need those rings if all applications were written in and compiled to WebAssembly. And so you could do some very interesting optimizations. There really is not a lot of precedence for this, so it's the long-term viability of it is open question, but it's kind of a really cool and exciting thing, because I would love to see WebAssembly be that gap, that bridging of native applications to web applications, and making it so that eventually the browser just gets absorbed into the operating system and there's no distinction. Because I think that's, Chrome OS is a perfect example of what does the future maybe look like, where the browser and the OS are one and the same. And I think WebAssembly really helps bridge that gap. I could see, like, this is a huge, huge bet type of thing, but I could see companies, like Apple and Google, with their Android and iOS, deciding to eventually support WebAssembly as a first-class application format instead of their proprietary solutions, because they both have to do sandboxing, and they both came up with their own proprietary way of doing that.
Right. Well, and they right now they're already supporting a JavaScript engine as an increasingly first-class way to develop applications. So this is kind of just one step further down the road, potentially more general.
Right.
Huh.
Yeah, and you could theoretically ship WebAssembly as in an app today on both those platforms, since they have they have JavaScript core and all that, and V8. I don't know of anyone who's doing so though.
Interesting. So stepping back a little bit to browsers, partially because a lot of our audience is kind of web developer focused. Firefox has really been pushing the edge on this. And I think, their super high performance compiler showing essentially they can, load and compile this stuff as fast as it comes over the wire is really highlighting the potential of WebAssembly. Is there any info out there about some of the other major browsers doing that level of optimization? I mean, I don't see as much news, but you're in the know.
Right.
Are Chrome and Edge and Safari, are those teams working on how do we get this thing, compiling as fast as it comes over the wire?
Oh, they absolutely are. They don't talk about it as much as Mozilla does. And there's, the last I checked, at least, they had streaming, like Chrome. I don't remember if it's in the actual release or if it was on the Canary that I was using, but Chrome did support streaming compilation. but the performance of it was not as what's the word? The tactful word. It was not as good as Firefox at the time. But it's it's an incremental thing, right? Like do make it. I really do subscribe to the make it work, make it right, make it fast type of mentality. And they do as well. I mean, I don't know if they officially subscribe to that, but they at least certainly act like they do. And and so there's a lot of room ahead for optimization in all these major browsers, and they kind of we'll go head to head. One thing will be faster in one browser, and then a totally other thing will be faster in the other browser, and it's the same world as JavaScript. Like one of the biggest things, and we'll touch on that I'm sure later, is just the calling into JavaScript performance. There's been a ton of work that's been prioritizing on making that faster, just so it's more practical.
Yeah, so that's actually an interesting area to explore. How easy or hard is it to access DOM and other APIs that right now you would access in JavaScript?
Mm-hmm. So that's one of the interesting things about WebAssembly currently, and one of the reasons why I attribute WebAssembly has not taken off is WebAssembly. So the community group and the working group definitely subscribe to the make it work, make it right, make it fast type of thing. And so everything's very minimal. MVP as far as the abilities and stuff like that. So in the MVP of WebAssembly, WebAssembly itself cannot access the DOM directly. It can't actually do any external I/O or side effects directly. So it can't make AJAX requests. It can't open files. It can't do signal interrupts. It can't do any of those external stuff. Instead, it has to call into JavaScript to do that. So JavaScript has to basically instantiate a WebAssembly module and say, hey, here are the functions you can call. And so it has to give bindings to DOM-related stuff. And in WebAssembly, currently, you can't pass around like a DOM node or manipulate DOM or anything like that because there's no concept of it. There's basically a giant linear memory that is a bunch of numbers, just like you would deal with native code, native machine code. There are no abstractions currently about like structs and objects and garbage collection and stuff like that. So because of that, there is a cost to calling into JavaScript. It is a bridge, and all of the browser vendors that I've looked at, actually I should just say I've only looked at how V8 and how WebKit or JavaScript Core does it, and in both those cases they use existing interfaces that have a lot of overhead. That's kind of unnecessary overhead, and they basically just took the simplest route, which I agree with. I think is great to not try and create new code that you think is going to be faster without proving that it really would be faster. But there's a lot of work being done to improve that speed. And at the same time, there is work being done in the specification process to make WebAssembly be able to access those things directly without even needing JavaScript involved at all. And that's, I think, going to be the key to WebAssembly's future, to make it open up, because right now we're in a situation where if you have a native background, if you've done C++, C, or Rust, or you have a desire to learn those things, WebAssembly is great for you. Like, it's a great use case. There's a lot of things you can do with it. But a lot of JavaScript people and a lot of browser web people don't have that background. And so, but they may have a Java background. They may have a C# background or desire, or they may want to use these hot new languages like Reason or Elm, and those other more dynamic languages, but still, like the big thing about all those languages I just listed is that they're all garbage collected. And versus C, C++, Rust, those are not garbage collected languages.
Right,
and
right.
So the ability to touch DOM directly really, it doesn't require having garbage collection, but it makes it. So one of the problems, so imagine this. If you're calling across the foreign function interface, you're calling across that bridge to JavaScript, and you create a DOM node, and that DOM node somehow is a reference inside WebAssembly. Well, how would WebAssembly know when to automatically collect that, to actually garbage collect that inside? If WebAssembly was just this giant linear memory like it is right now, you wouldn't be able to know. Like it wouldn't work well. It wouldn't work at all. And so you can do tricks like the current implementations of languages compiling to WebAssembly that require garbage collection do tricks to work around this, that they work, but they don't perform as well as they should. And so WebAssembly really needs first-class support for the underlying garbage collector that's in the virtual machine. The same garbage collector that JavaScript is using, WebAssembly will get access to. And that's all going to be, that's not something that like you as a language person, like if you're not a compiler author, you're not going to have to deal with this. Like to you, it just means that your Java, your C++, or your Java, your C#, your Elm, those will just work correctly. But as a compiler author, this is all very important information to make the languages efficient. And that's why a lot of languages have been holding out. C# has done a ton of experimentation, and they've got the Blazor stuff that compiles to WebAssembly that works pretty well. Go, another garbage collected language, just released their ability to compile to WebAssembly, but it doesn't perform as great, and the binaries are kind of bloated. That's a common theme that you're going to see when a new language decides to target WebAssembly for the first time. Is things are going to be slow at first, and your binaries are going to be bloated. That's a pretty normal thing, because make it work, make it right, make it fast, right? So to do it in those order. If they try and skip the first two steps and go right to making something fast or small, you fail. You take longer. You don't do it right. It's just better to follow it in those steps. But I realize how frustrating it can be, because some people are like, "Oh, WebAssembly is supposed to be this, smaller and faster, but yet it's bigger and slower than JavaScript." And that's, JavaScript, it's just not fair, because JavaScript has had so many years to be optimized. Really, when we're talking about the benefits of WebAssembly, we're talking about the hypothetical benefits that can be attained. We've basically lifted that ceiling that exists on JavaScript. So there's a ceiling, like using JavaScript as a compilation target, there's a ceiling, we know. And WebAssembly lifts that ceiling much higher so that we can get better performance. But it's going to take time. It really is.
This episode of JS Party is brought to you by Hired. One thing people hate doing is searching for a new job. It's so painful to search through open positions on every job board under the sun. The process to find a new job is such a mess. If only there was an easier way. Well, I'm here to tell you there is. Our friends at Hired have made it so companies send you offers with salary, benefits, and even equity up front. All you have to do is answer a few questions to showcase who you are and what type of job you're looking for. They work with more than 6,000 companies, from startups to large publicly traded companies, and 14 major tech hubs in North America and Europe. You get to see all of your interview requests. You can accept, reject, or make changes to their offer even before you talk with anyone. And here's the kicker. It's totally free. This isn't going to cost you anything. It's not like you have to go there and spend money to get this opportunity. And if you get a job through Hired, they're even going to give you a bonus. It's normally $300, but since you're a listener of JS Party, they're going to give you $600 instead. And even if you're not looking for a job, you can refer a friend, and Hired will send you a check for, get this, $1,337 when they accept the job. As you can see, Hired makes it too easy. Get started at hired.com/JS Party.
Suz, you're often doing some pretty interesting edge cases of stuff, web USB, funny gaming stuff, things like that. Like, what's your take on WebAssembly and where things are?
I feel like that's such an accurate description. I feel like always the edge case with everything that I'm trying to do. I'm really interested in WebAssembly for, like, obviously these load times are amazing with the streaming compilations, but once you've actually downloaded the WASM package or the module, and you're running it, I'm interested in what WebAssembly is actually really good at with regards to what it can run. So, I've been reading things about it, and I'm seeing that it's good at things like crunching numbers, which obviously makes me think of things like gaming, but I also want to see if we can hack it to just be able to port tools that normally run in something like, just on your desktop with C or, in even lower level language than that, I'm wondering, can we port things to the browser similar to what we used to kind of use in Scriptum for? Like, that's what I want to know.
Well, absolutely. You're 100% right that, because it's such a low level target, the things that people are going to, the things that it is absolute best at is crunching number type of things. Because, in JavaScript, the virtual machine can only do so much about us making assumptions about the various types of things. And you have to be very careful to not, type your code in a certain way so that it doesn't, de-optimize and stuff like that. Whereas with WebAssembly, it's very strictly typed and there's a lot of optimizations it's able to do. So like that being said, like things that are technically end up being crunching numbers and you may not realize that it is crunching numbers is like, I don't know if you guys have seen the source, so there's a project Mozilla maintains called Source Maps. Source Map is the NPM name. And as it sounds, it's for creating and reading source map files for JavaScript. And it's actually the library that the Mozilla DevTools uses. It's the same source map library that Babel uses and Less and a bunch of projects. It's one of the most popular, it is the most popular source map implementation. And they thought the exact same thing. They said, is this something that, we should try and compile this to WebAssembly? Like they had it written in JavaScript before. So then what they did is they ported it to Rust and then compiled that Rust to WebAssembly. And their very first version of it was 5.8 times faster than the JavaScript implementation.
Wow.
And they did a little bit of tweaking, a little bit of algorithmic improvements, just basically taking advantage of knowledge of the fact that it's going to be compiled to a much more native target. And right now it's 10.9 times faster. And so I know I appreciate that when my Babel builds and, the dev tools and all that stuff, but that's just an example. Now, certainly it is possible to create examples that are actually even slower than JavaScript. And that surprises a lot of people. A lot of people say, well, how can that be possible? And that's ultimately just because JavaScript has had a lot more time to be optimized. And because JavaScript is a much higher level language, so think of it this way. When you create a class in JavaScript, the underlying virtual machine has a notion of objects and classes. It knows what a class is and what an object is and can use that knowledge to make optimizations because it can make assumptions based on that. However, with WebAssembly, currently, there actually is no object model. There's no knowledge of objects. You can think of a typed array. Like, I don't know if you're familiar with typed arrays, or just a regular array in JavaScript. Think of a regular array in JavaScript and imagine all you can do is add and remove numbers in that array. And welcome to WebAssembly. Because that's essentially what it all boils down to. I mean, that's kind of oversimplifying it a little bit, but it just gives you the example of the WebAssembly virtual machine has no knowledge of objects and classes and stuff. If your language you're programming in has those, they get desugared down. They get compiled down to, loads and stores into this linear memory. And it's all, like where the start and the end of a class in memory is a convention, essentially. Like the compiler knows just by convention and by keeping track of that at compile time rather than at runtime. Typically in most languages.
Aren't those types of optimizations what your compiler to WebAssembly would do? Like we're moving the toolchain out of the browser and into the compiler.
That's exactly right. However, there is a limitation of that the compiler in this case doesn't know the underlying machine code. And so it can't utilize,
right.
You know what I'm saying? So like can only compile to WebAssembly. And WebAssembly doesn't have all the tricks in the book for it because like CPUs these days, modern real native CPUs have a lot of exotic instructions and things that you can do for special cases to increase performance. And WebAssembly, you don't get direct access to those things. And there's no way to like hint to the virtual machine, hey, use this specific instruction or whatever if it's available. And so the WebAssembly virtual machines, it's really up to them to try and deduce these types of things. And, I don't want to focus too much on that example because it's just an example. But the point being is that there's always going to be cases where WebAssembly can be slower than something that is a little more high level and has more, the virtual machine has more knowledge of. But by and large, once WebAssembly has had a bunch of time, in the wild, and they've improved the optimizations around the compilations that they do, then WebAssembly will beat JavaScript in a large majority of cases. It may not be true today in every case, but in a large majority of cases, it will beat it.
That kind of underlying tooling stuff is really interesting to me. One of the things that I was thinking about as I was doing research for this episode is, like, if you look at what's going on in, and I'm a web front end guy, so I'm thinking in that world, but you look at like what React is doing with their new architecture. They're under the, behind the hood, slicing and dicing work and doing all sorts of kind of magic compilation computation things that your application never has to worry about, and then running them out. That could be happening in WebAssembly.
Oh, absolutely. And the only reason it's not, at least in my opinion, I don't want to speak for them, but I've talked to Sebastian and a couple other people on the React core team about this because I'm a big advocate for WebAssembly. And ultimately, it comes down to the bridge. It comes down to the garbage collection and the fact that WebAssembly has to call across that JavaScript bridge. They're just not interested in doing a lot of effort or a lot of commitment into something that has a potential of being slow. But at the same time, there's projects like the Glimmer virtual machine for Ember. The Ember is another competing UI framework, and they've got the Glimmer engine is their underlying how their underlying rendering works. And they've recently actually started an effort to actually implement their virtual machine in Rust that compiles to WebAssembly. And at this point, this is almost a year in the making, if not more. And in a lot of ways, it's a research project because it is unknown whether, in the end, the performance benefits of WebAssembly itself will get negated enough by the cost of calling across into JavaScript. Some initial benchmarks suggest that sometimes it does, sometimes it doesn't, that type of stuff, but it is a little too early to tell definitively whether it's going to be a win. In the long term, it's without a doubt going to be a win. It's just
when.
Yeah, exactly. Unfortunately, and if you're doing things like games, like you can get great performance right now today in games, just because you don't need to cross that bridge super often. But when you're touching DOM and stuff like that, what you have to do, you don't have to do, but to really get Glimmer Ember style performance, you have to batch up your changes and send those changes in like a change list across the wire and then across that bridge, and then apply those changes at a single time, just to minimize the cost of that bridge. But I think that bridge performance is I don't think it definitely is going to increase significantly over the coming years.
Suz, did you have other examples in mind that you were curious about?
I really just want to have a compiler compiled into WebAssembly. That's what I want to see. You look at those websites like RepelIt and other websites that allow you to essentially be editing things in the actual browser. And this is the missing puzzle piece for me on a personal project where, I would love to be able to move something like AVRG++ to be able to be run in the browser. And the bridge isn't too bad with passing over something as small as, a C++ file to compile using that. And so I guess I'm interested in that Inception-y thing, in that how hard is it to port existing tools that might be written in C++ or Rust? I know that there's some work you need to do, or you even need to kind of write these sort of pseudo interfaces in order to get that cleanly coming over. What are the current challenges in people being able to do probably more sort of unique projects like that?
So Mscripton you mentioned earlier, which is a project that the folks, one of the guys who's at Mozilla created originally, and it was designed for a predecessor of WebAssembly called AWSM. And I'm not going to talk too much about that, but it was essentially a predecessor, an attempt to do something similar to WebAssembly before this. And they were able to reuse a lot of that architecture. And now Mscripton's primary goal is WebAssembly. And so Mscripton, if you've got a C or C++ project, it's definitely the way to go. It basically wraps on top of Clang, and it uses the same arguments and everything. And instead, the main thing that Mscripton these days provides is a standard library, an implementation of the standard library for the browser. So, especially right now, because of the bridge to JavaScript, some of these things have to be implemented in JavaScript. And so it comes with all of that stuff. And I have helped several people with their existing C++ projects. And I think most people are going to be surprised at how little they need to do to get their projects working in WebAssembly, their C++ projects. Now, it ultimately is going to depend. Like the issues you'll run into are most likely things like platform specific APIs, and even then, though, some of those platform specific APIs have been shimmed out and will just naturally work. But like if you're, especially on the graphics side of things, you may have to do some if defs where you're saying, if it's a Mac platform, use this. Otherwise, if it's WebAssembly, call this header from Emscripten. Emscripten provides headers for accessing HTML5 and all that. So it takes care of that for you. You just have to call them. But a lot of the, like, for example, if you're touching the file system, all of that stuff gets emulated in Emscripten automatically for you. If you're using anything from the standard library, it will just be automatic and you don't have to do anything special. You might find other edges. Multi-threaded environment is not currently, it was working for a little bit and now it's not working because of the Spectre and Meltdown exploits. The browsers had to disable shared array buffers, and shared array buffer is required to be able to do the multi-threading. So it currently does not work. That's one deal breaker for a lot of people who have C++ stuff, is they might be surprised where they have threads.
Is that something that's under active development to fix? Because I feel like one of the things that's really exciting about WebAssembly is the potential of a fine-grained parallelism approach in the browser.
Right.
Lynn Clark, we were talking about Lynn Clark earlier. I saw a keynote that she did recently where she's talking about parallelizing everything in the browser, because we know that parallelization is the way to unlock continued performance gains at this point. And client code is the one place that's very hard to do that, because JavaScript's primitives for parallelization, web workers or whatever, they're pretty coarse-grained. They're hard to use for a lot of situations. But if you could use Rust, which is very good at writing fine-grained parallel code, and compile to WebAssembly and just have it run, like that unlocks a huge amount.
Right. Yeah, I don't know the latest from the browser vendors, other than the last thing I knew was that they were doing research on the best ways to be able to unlock shared array buffer without exposing those exploits again. They mentioned it in one of the community group meetings a couple weeks back, and they seemed confident that it was like they talked about it in a way of like when we re-enable it, not if we re-enable it. So I'm assuming that they have confidence in it, but I unfortunately don't know specific timelines. There has been talk. So currently, WebAssembly, when you do multi-threading, if shared array buffer was exposed in the browser, it does actually use web workers technically. Now, that's not, when you're doing something like C++ or Rust, that's actually not a big deal. The only big deal about that is that the cost of spinning up a new one, the cost of spinning up a new thread is, relatively cheap compared to the cost of spinning up a new web worker. In a lot of ways that can be helped by pooling and stuff like that. But otherwise, like once the web worker, aka thread in this case, is spinned up, then there's no major issues on performance or something like that, and you don't have to deal with like the transferability, because again, with Rust and C++, everything ends up just being numbers, and you're able to access that through the shared array buffer, which is one of the problems with JavaScript is, you can't send a class or an object over the wire without it being serialized, because that would be unsafe. But with shared array buffers, because they're just numbers, you can use the atomic operations to lock and wait for the different values across threads and stuff like that. And those abstractions get compiled away. But there has been talk. My point of that was there has been talk actually, even in the last community group meeting, which I think was either yesterday or the day before, I can't remember, of do we expose real threads like pthread type of things to WebAssembly? And it's a contentious subject, because it sounds like my take on it at this point is the answer is yes, but the answer is not right now, because it's a really, really big undertaking. Like, because it really, once you expose real pthreads, it indirectly makes JavaScript multi-threaded, whether you want it to be or not. Because now you have concurrent threads that can call into JavaScript concurrently and create races within JavaScript itself. And the existing virtual machines for JavaScript are not thread safe. Like they are not like, so there'd be a lot of work that would need to be done to make JavaScript itself work correctly in a world where you can call into it from a multi-threaded environment, a true multi-threaded environment.
Oh, that's interesting. Yeah, I wonder if you could essentially create a, Ruby style global interpreter lock on the JavaScript piece. And so like you have these things running along, but then as soon as they call into JavaScript, suddenly it's serialized.
Right. Yeah, like something similar. Because like right now, essentially when you do the web worker style stuff, it's fine. Like you have true multi-threaded in a way with your WebAssembly contexts. But as soon as you want to call into JavaScript, if you're not on the main thread, the only way to do it is to post message, that's what saves JavaScript today from that complexity, is you have to post message. So you can't create those races. I mean, you can create races, but not in the same. It's not the same type of race, not an actual language level race where the compiler has to be aware of these things. Like you can be, if you haven't dealt with actual like very low level races before, not you, but everyone in general, they can be very unintuitive, and very difficult. So I empathize with the browser vendors pushing back on it. I think they've done a good job of acknowledging that it's an inevitability, but realizing that there are bigger fish to fry right now. And, we want to focus on the host bindings. We want to focus on the garbage collection. And if we focus on the multi-threading, that's just going to take away time and push back those implement the GC and the host binding stuff. So I think that they've got it,
and that's part of make it fast, right?
Right.
Like first they're working on make it work, make it right, and then
make it fast.
Finally, we'll work on make it fast.
Hey everyone, I'm Tim Smith, senior producer here at Changelog. You know how important it is to stay in the know, and our weekly newsletter helps you and thousands of other developers do exactly that. It's the developer news that matters, nothing more and nothing less. Visit changelog.com and subscribe today.
So let's count this as we're rolling in, and I think it's your weird idea, but I actually think there's actually something really key and interesting there, and two pieces actually. So one is in terms of distribution, right? So folks who are coding in these other languages, who want something that's more native level performance, but want to be able to tap into the greatest distribution network in the world, which is the internet and the browser. But then the other one that I think is interesting is something we've touched on a few times, which is learnability. The tools like JS Fiddle and CodePen and things like that essentially give you a browser environment for development and for sharing code have dramatically accelerated the ability of people to learn web development technologies. If we can get compilation and runtime and all of that working in the browser, like what does that do for the learnability of all of these previously kind of systems languages where you had to do a lot of local setup?
Yeah, that's what I want. I want us to stop like having to call out to a cloud service to compile the code that you're writing in the browser IDE, right? I want someone to plug an Arduino in. They're using WebUSB to be able to upload the code, but it needs to be compiled first. And if that's all happening completely offline and they can open a browser that's even just running stuff in like local storage, that to me is where we've finally hit the point where you've got easily distributable educational, resources like that. I think you totally hit the nail on the head there as to why at least I'm so excited about it.
I totally agree.
So a lot of the toolchain right now is built on, they're using an LLVM backend, right, to output WebAssembly?
That's right. Yeah, there's a bunch of community. So there's stuff like Binarian and Wabbit and stuff, but those are early projects to, for experimentation and optimization and stuff. But the primary the primary goal is to use LLVM, and most tooling will end up using LLVM to generate their WebAssembly.
Well, and LLVM is pretty mature. So most compilers, focus on bootstrapping, right? Like, how do I compile myself with myself? So has anybody tried bootstrapping LLVM with WebAssembly?
Yep. It does work. And in fact, there's a bunch of different stuff. Like it doesn't work for every case, but yes, it's been done. There's also JavaScript core itself, which is the JavaScript engine for Safari. It has been compiled to WebAssembly. So you can run JavaScript core in JavaScript core through WebAssembly. And it actually was faster than you might expect. Like it was like, that was actually surprisingly fast.
Did it create a speed increase, or it was?
No, that would be hilarious though if that was the case.
That would break my brain.
Yeah, that would break my brain as too. Like theoretically, that could be possible. Like it is definitely.
Oh, you know what it would let you do though? It would let you test JavaScript core in Edge or in Chrome. Like you could embed Safari's JavaScript engine into other browsers.
Oh yeah,
that's a whole new level of those standardized unit tests that they're now running.
I'm sorry, was that a question?
Well, no, I'm just starting to think about it. Like, what if you could compile, for example, Chakra Core to WebAssembly as well? Could you? How many layers of JavaScript engines could you run?
Right.
That's how you cheat and get threads.
Right. Exactly. Yeah.
So we could run. Can we run a JavaScript engine in a web worker or something like that? Can we have like calling up back and forth between all of these different engines?
Oh,
there's going to be a trade-off there.
Yeah. There's always a cost. I mean, like theoretically, being able to right now, there is not an easy way. It's possible, but it's not an easy way to JIT your WebAssembly to actually send a JIT. Like, let's say that you wanted to do an implementation of JavaScript and compile that implementation of JavaScript, a JavaScript virtual machine to compile the WebAssembly. You could do it today, but generating new WebAssembly code on demand, like via just-in-time compilation, is just not up. There's no first-class support for that within WebAssembly itself. Because again, you got to call it to JavaScript, create a new WebAssembly module from JavaScript, and that that has a cost, especially for small. If all you're doing is trying to JIT a single function, that's just not going to be worth it. But it is definitely a stated goal. We're going to get there. It just takes time.
This is kind of amazing. So we touched a little bit on tool chains, and that was one of the things that was kind of interesting. You're looking around. Somebody's done a doc of like all the different languages that have compiled to WebAssembly support, and there's like 20 or 30 different environments that support this at this point.
Sure. Yep. Mm-hmm. Is that the WASM website, or is that a different one?
It might have been. Let me look. I actually wrote a blog post about WASM. I got so excited getting ready for this episode that, well, it was funny, right? I was working on this episode and then I was like, this is really cool. And so I went on Quora and was starting to answer questions, and that got me more excited. And I was like, I got to write a blog post about this. So I went and wrote a post about, sort of how WebAssembly is accelerating the future of web development and kind of what it's potentially going to enable. Let's see. So I have a link to that. Yeah, it was the awesome WASM langs. That's what it was. So that's the list of environments, and it's got, your esoteric languages like brain is written in, has a compiler, and,
of course.
It's Prolog and things like that. But there's also like C#, C++, the whole .NET environment, Python, Haskell, Java, Go, like all of these things are now capable of compiling to WebAssembly.
They're just not production ready, though. A lot of those are not production ready, unfortunately.
Which ones would you say are?
Rust and C++ are by far the biggest ones that are production ready. Those, I would have full confidence in using those in production. Any of the dynamic ones, any ones that require garbage collection and all that stuff, you may be able to use it in production, but you're definitely going to be an early adopter. Go, for example, had to do a lot of clever tricks to work around they essentially spill their entire call stack into linear memory so that they can do garbage collection on it. And that has a pretty big cost. And it's a temporary trade-off, right, until WebAssembly gets that GC support or the ability to introspect the call stack within. Like this is getting pretty low level, but the WebAssembly stack, it's a stack machine, and you can't currently introspect that stack. So there's to do any kind of garbage collection within your language, you have to basically duplicate or move the your pointers and your stuff that maybe locally on, like you would normally have on the stack, has to actually get in linear memory. Like essentially you can think of it as even things you would normally do on the stack, you have to do on the heap. And so that, I hopefully, if you know a little bit about stack versus heap, that can give you an example of that it's going to be expensive to be spilling these things into that linear memory.
Yeah, as a highlight of how expensive that is, I saw a thing recently that it's just sort of an aside, but Microsoft Edge sped up some form of array looping by 2.5x by changing the implementation from C++ to JavaScript of all things. But the main reason was that let them shift their memory, so they were able to shift from heap to stack.
Interesting. You have to share that link with me later because I'd love to read that.
It was pretty. I saw that and I was like, so you're speeding up your JavaScript by going from a native implementation to writing it in JavaScript.
I love that.
And that's, I think, one of the hard things. It's the hardest thing about talking about performance, and WebAssembly is no different, is nuance, right? I can say it's faster, but that's not always true, right? There's certainly going to be cases where JavaScript's faster, especially now because it's so early. And I think that's, the trouble people have is they get so, they latch onto a specific phrase and then they try and prove how wrong it is. They're like, oh, WebAssembly, they're like, oh, the binaries are small, huh? Well, I'm going to go and use this brand new tool chain that just got released and complain about how the binaries are 10 megs or something. It's true that especially from the native world, so think about it this way: the native world, for the most part, has not really had to care about file size. It's within reason, right? You don't want a 2 gigabyte executable, but the difference between 1 byte and a meg is really pointless in the native world for the most part. And so they haven't really focused on those types of optimizations historically. So the toolchain stuff that compiles to WebAssembly, the early on stuff, and it's already gotten way better, but early on, it was pretty bad. Like, it would not be unusual to compile the WebAssembly and get 20 meg files. And they've gotten super improvements on that. And now, with Rust and C++ with the right flags and stuff, you can get that down to just a couple of K for just for a simple hello world. But there's a lot of trade-offs, right? So one of the biggest things, ironically, for Rust and C++ is you need a way to allocate memory on the heap. And so your malloc and your free. And malloc and free are actually fairly large implementations for most of them. There's a bunch of there's the ones that come with built into the operating systems and stuff, but then there's community-based ones. Rust uses a totally different one by default than OS ones because they have different trade-offs. But all of those allocators the trade-off was, one of the trade-offs they did was having more code, you'd have bigger binary size, smaller heap usage overall, fragmentation and stuff like that. So one of the choices people are going to have to make, and Rust is actually Rust and C++, are both the people who are working on the WebAssembly implementations are both working on smaller allocators that will make the opposite trade-off of you can choose. You can say, I want a smaller bundle at the expense of having slower allocations. Because you can't. It's all physics, right? It's give and take. You can't just magically create things be fast. So it'll depend on the project. If you're trying to a perfect example of it is if you're just trying to compile to WebAssembly a small library, tiny little library, you may want to use the smaller allocator that trades file size for performance. If you're writing your entire app in a language that compiles to WebAssembly, you probably don't care about that. You probably want the better allocator because that size is essentially amortized. That if the allocator is 2 kilobytes, in the grand scheme of your app, 2 kilobytes means nothing, right? So it's it'd be worth that performance difference. And we're not talking slow versus fast. We're just talking, micro benchmarks, especially when it comes to very small allocations.
So here's an interesting question along these lines. So what we're describing here if we were going to the, compiled language world, is basically everything is statically linked, right? You're embedding all of these libraries that you're going to use in your binary that you're going to ship. Is there anything on the horizon that looks like essentially dynamic systems libraries, so that the browsers and whatever VMs would have a standard malloc implementation that you could dynamically link to and not have to ship that over the wire?
You can think of anything you import from the WebAssembly module, or when you say import, you're not doing that in your C++ or your Rust, but the compiler does it. So because WebAssembly can't do anything external without JavaScript, you already are doing dynamic linking always. You can't use WebAssembly in the browser today without dynamic linking something. And as far as the browser providing something, it's going to provide the host bindings eventually. So you'll be able to create DOM nodes and print to the log and all that. So that's technically going to be dynamically linked. As far as providing standard library stuff like malloc and free, or SBRK, like the lower end ones of those, there's been discussions. It's tough because it's such an opinionated thing, right? Malloc is even something that most people would, if you know about malloc, you might not even realize that there are lots of implementations of malloc, and that's an opinionated thing. So instead of that, one of the focuses has been also making the caching story easier, so that becomes less of an issue. You can imagine there being lots of CDN links for standard library stuff. You pull in the C standard library, and that just gets cached and reused across, cross origin between all the different WebAssembly applications and stuff like that. So the fact not just the file gets cached, but the compilation itself gets cached. So the fact that it's, a different file doesn't really, it's not really that important. That's not doable today, but that is definitely something that's been considered and talked about, and a goal is to make those type of use cases easier, just so that code can get reused, especially when things you can have a lot of excess file size that it's kind of a pain, because it's kind of goes back to the jQuery days, right, where every website had jQuery, and it's well, wouldn't it be nice if everyone just shared the same jQuery?
Yep, and we got that with CDNs, and then we introduced module bundlers, and now we've thrown it
exactly,
away.
And then we walked away from it. Yeah, But there's some things where in the JavaScript world things move very quickly, whereas in some of the standard library worlds they move very slowly. Malloc doesn't really change for the most part for a lot of standard libraries. There's always going to be new implementations and stuff like that, but the caching those things heavily is definitely something we're going to want to do at some point. Whether the browser will expose those things directly itself, provide its own opinionated malloc and free, if I had to guess, I would say they won't. It's just too contentious. I just can't see that happening.
Suz, anything else on your mind for WebAssembly? You said coming in you had lots of questions.
Yeah, I think that I'm thinking about this from the web developer perspective, who works 9 to 5 at a company that, they work on a product that gets released on the web. Given that this is so early on, and given that there's a few already performance based benefits for starting to use WebAssembly, are there any low-hanging fruit that they can sort of focus on for now while they're waiting for it to be ready, where they can sort of arm themselves with enough knowledge to start using this stuff to improve the product that they're already working on, I guess? How is it relevant to, the day-to-day web developer right now?
Well, aside from the fact that, you're probably already using WebAssembly. Actually, I would argue that almost every single person listening to this is probably using WebAssembly without knowing it. Going back to that source map is an example of one of the many projects that have been ported to WebAssembly that we all use, just transparently. I would say if you're, I personally, even though I'm super obsessed with WebAssembly and super excited about it, I don't try and advocate people force themselves, or I don't super advocate, try and find somewhere just to use WebAssembly for the sake of. So certainly the average CRUD app where all you do is just, you read, most applications are this way. You just read files or read data from an API and then update those forms and stuff like that. those things are not going to be super benefit from WebAssembly at this point. I would not recommend going down that route. But if you do with a lot of, if you do deal with, as you guys were saying, kind of weird things, I would say the more weird it is, the probably more likely it's a good fit for WebAssembly at this point. Like things without anything with dealing with algorithmic anything. Like if you're dealing with algorithms, it's probably a great fit for WebAssembly. Graphics in general as well. And in the future, WebAssembly is going to get SIMD, which is that single instruction, multiple data. It's really useful for doing vector-based stuff. Really, I want people to be more aware and excited about WebAssembly so that the browsers focus more on it as well, so that the revolution that I think is coming gets sped up, right? And in a perfect world, like I'm envisioning 5 years from now, you don't really need to know anything about WebAssembly. Like it's just an implementation detail of the language you're using, right? Just like machine code. Like how many people compile for iOS and know anything about the ARM instruction set? Probably a tiny, tiny fraction of people doing that. And so they don't need to know how their code gets compiled and runs on the native thing. It just works. We're not quite there yet with WebAssembly because it's so early, but that's the goal, is that you will just be able to transparently take advantage of it. You'll be able to use your Reason, your Elm, or some brand new language that hasn't even existed yet, and transparently compile to WebAssembly, and everything just works.
All right, thank you for tuning in to JS Party this week. Tune in live on Thursdays at 1 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. And do us a favor, share this show with a friend, rate us on Apple Podcast, go into Overcast and favorite it. And thank you to Fastly, our bandwidth partner. Head to fastly.com to learn more. And we move fast to fix things around here at Changelog because of Rollbar. Check them out at rollbar.com. We're hosted on Linode Cloud servers. Head to linode.com/changelog. Check them out and support this show. Our music is produced by Breakmaster Cylinder. And you can find more shows just like this at changelog.com. Thanks for tuning in. We'll see you next week.